Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we'll support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable EC student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code ANKITESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code ANKITESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code AnkitESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the last few videos I have talked to you about feedback amplifiers and how to tackle the different types of feedback and what kind of amplifier is realized using each feedback. But now we'll be focusing our discussion to an entirely different topic that is called as oscillators. Oscillators are entirely separate from amplifier. They don't lie in the category of amplifier, so neither you can classify them in feedback amplifier or any other amplifier for that matter. But they are a very important element in circuit analysis, in circuit designing, in analog designing. Oscillators are very important, okay? And from even gate or ESE point of view, oscillators play a very important role. So first let us start our discussion from something that you might have used in your laboratory, that is called as the function generator. Now you might have already seen function generator sitting in your laboratory. So my first question to you is, what is this function generator? Now those of you who have used it will say that we use function generator to apply different kind of waveforms. Absolutely right. Function generator is a device that can generate different waveforms. Now what kind of waveforms? Like square wave, like triangular wave, like sawtooth wave, like sinusoidal wave. All these kind of waves can be generated using a function generator. Okay, but does it do any other thing than generating the waveform? Yes. You can also control the frequency, and amplitude of waveform. That also can be done using the function generator. So why is this important? If you have done the lab in which you will be using CRO, for that you always need an input signal, and that input signal is always taken using a function generator. Think like this. Suppose I have designed a circuit. Now I want to simulate that circuit. I want to see the response of that circuit, and to observe the response you need to apply the input. That input waveform itself is being generated by function generator. So what does function generator do? It generates a waveform that can be used to excite the circuit in order to represent or in order to observe the response of the circuit, and that is the functionality of the function generator. Okay. Now for function generator, oscillator is the most important part. Okay. So oscillator is the most important part when we are designing a function generator, and that is why we are moving our study towards oscillator. Now what is an oscillator? An oscillator is a device that can produce an oscillating waveform, or that can produce a waveform which fluctuates between two values. Okay. That is, if I produce a waveform that oscillates between 5 volt and 10 volt, then that device will be called as an oscillator. Oscillator comes from oscillation. Oscillation means motion between two or more than two states. Okay. Now if your oscillator generates sinusoidal waveform, if the oscillator is generating sinusoidal waveform, then it is said to be harmonic oscillator. If it generates square wave, triangle wave or sawtooth wave, that is other waveforms, then it is said to be relaxation oscillator. So sinusoidal oscillators are called as harmonic oscillator and non-sinusoidal oscillators are called as relaxation oscillator. Now the major difference between amplifier and oscillator is that with oscillator we make use of positive feedback. Okay, always we will make use of positive feedback when we are using oscillator. See this block diagram. The sign or the symbol with the feedback signal is positive. That means it is being added into the supply, or you can say the input signal Xi is sum of supply signal and the feedback signal. So that is why it is called as the positive feedback, because the feedback signal is getting added to the input signal. Okay. Now oscillators are very important. Why oscillators are important? Because they are used in communication equipment. Those who are from ECE background will know that without oscillator we cannot design the receiver as well as the modulators. Okay. So in modulation they will be used for generating carrier wave, for amplitude modulation, frequency modulation. Okay. And they can also be used in transmitter and receiver. Then oscillators can be used in clocks, because in digital we need a clock signal that is a square wave, and that wave is generated using a oscillator. Okay. And also oscillators are sometimes used in triggering SCR, that is for electrical guys. In power electronics we make use of UJT oscillator in order to trigger the thyristor or SCR. Now let us understand how does an oscillator work. See, first of all let me come in terms of voltage instead of this X. So I am saying the forward path gain is A, similar to feedback amplifier. The forward path gain is A and the feedback gain is beta. This I will call as Vi or Vs, Vi, V0. Now you can say that this feedback voltage is beta V0. Now suppose initially I am explaining the working. Initially V0 is 0, that means Vf is 0. If Vf is 0, this Vi is actually Vs plus Vf. It will be equal to Vs, and V0 will become AVi or AVs. So initially V0 was 0, but due to supply voltage V0 is becoming AVs. Now this voltage will generate the feedback voltage, which is beta V0, or you can say A beta Vs. Okay. Now if somehow you manage to make A beta equal to 1, then Vf is equal to Vs. So we don't need Vs, because now the feedback voltage itself will work as the supply voltage. You don't need any supply voltage, or you can say the supply can be removed. So we can say this oscillations will be now self-sustained. Self-sustained means without the need of any external source or any external supply. The oscillations can go on by itself. You don't need to connect any external equipment. Okay. So oscillations will be self-sustained if you make A beta equal to 1. This A beta is called as the loop gain. Similarly, in control system, you call GH as the loop gain, but here we are not using G and H, but we are using A and the beta. Okay. And this criteria is called as the Barkhausen criteria. So let us discuss upon Barkhausen criteria. So what we say, Barkhausen criteria says that A beta is equal to 1 for sustained oscillations. Okay. So that means the loop gain, the gain when traversing the closed loop should be equal to 1, or you can say it should be 1 angle 0. That is, magnitude of A beta must be equal to 1, whereas the angle of A beta should be 0, 2 pi, 4 pi, 6 pi, etc. Okay. The angle should be a multiple of 2 pi, or you can say the angle must be 0. So that is called as your Barkhausen criteria. It is a criteria which tells us under what condition the oscillation can be sustained. Now suppose if I take A beta less than 1. Just now I showed you feedback voltage was A beta Vs. It means that feedback voltage will be less than the supply voltage. If feedback voltage is less than supply voltage, V0, which is A Vi, will decrease. V0 decreasing means feedback decreases further, and if feedback decreases further, V0 decreases further. So V0 will continue to decrease. So how will V0 look like? If A beta is less than 1, the input voltage is reducing, due to which output reduces, due to which feedback reduces, and V0 reduces further. So it will be like this. Okay. So oscillations will die out. They will not be sustained. Now case 2. Suppose A beta is kept greater than 1. Then Vf equal to A beta Vs means if A beta is greater than 1, it is greater than Vs. V0, which is A Vi, will increase. If V0 increases, Vf is beta V0. It will further increase, which will again increase V0. That means in this case, the oscillation will go on increasing, and V0 will go on increasing rather than being sustained. So for sustained oscillation having a constant amplitude, you need A beta to be equal to 1, otherwise oscillations will grow. Either oscillation will die out or oscillation will grow. That is why we keep the value of A beta as close to unity as possible, even if it is not exactly unity. If you can't keep it exactly unity, then keep it as close to unity as possible. Okay. So remember, Barkhausen criteria says that product of A and beta should be 1. What is A? A is the gain of the amplifier in the forward path. Beta is the feedback factor. So I am saying A is the gain of amplifier in forward path, and beta is the feedback factor. Okay, product of them should always be 1. But suppose if I am using an inverting amplifier, in forward path if I am using an inverting amplifier, that means it is providing how much phase shift? 180 degree phase shift. But the net phase shift should be 0 degree or 360 degree. That means for Barkhausen criteria, angle of beta must also be 180 degree, such that angle of A beta is integral multiple of 2 pi. Is it fine? So even if you have an inverting amplifier whose gain is negative or it has a phase shift of 180 degree, then feedback must be designed in such a manner that feedback is also providing a phase shift of 180 degree, so that overall phase shift is 0 degree or 360 degree. Now suppose I take an amplifier, suppose I take an oscillator. This is the forward path. This is our beta, Vf, suppose Vi, V0. Now this Vf is actually beta V0, or you can say beta is Vf by V0. Since the voltages are AC voltages, they will have magnitude as well as angle. So I'll say beta is a complex number in which it has real part as well as imaginary part. But A is always real. Gain of the amplifier is always a real value. Okay, we are operating in the midband range. In midband range, gain is always real. Gain is not a function of frequency. Okay. So now when you talk about the Barkhausen criteria that A beta is equal to 1, then that means A into beta real plus J A into beta imaginary should be 1. This is real quantity. That means if you compare both the sides, the imaginary part of the left hand side must be 0. Or you can say beta imaginary must be 0. And beta real must be 1 upon A. So that is how we apply the Barkhausen criteria when we will be seeing different type of oscillators. You just have to remember, you have to make imaginary part of beta equal to 0 and real part of beta equal to 1 upon A. Then your Barkhausen criteria can be satisfied. So what does Barkhausen criteria says? If you make the loop gain equal to unity, then the feedback signal can itself work as the input signal. You no longer need the input signal and oscillations will be self-sustained. Okay. So that means the feedback signal can also work as the input signal. Okay. Then input signal is no longer required in a oscillator. Now the question that comes to mind is, what is the difference between amplifier and oscillator? Now when you talk about amplifier, what does it do? It increases the amplitude and power of AC input signal, right? Now where does this power come from? This power is derived from DC biasing. Okay, the DC sources that we have connected, they will supply this power. What does an oscillator do? It generates an oscillating waveform without any external source. Okay, without the help of any external source, it can generate an oscillating waveform, and the frequency and other parameters of waveform, most importantly frequency, are controlled by passive components such as resistance, inductance, capacitance connected in the oscillator circuit. Okay, so we will control the waveform parameter, mainly frequency, using the passive components that we have connected in the oscillator. Is it fine? Now, what are the different type of oscillators that we will be studying in this topic? See, the oscillators are mainly classified into two categories. One is called as the audio frequency oscillator. Audio frequency means the frequency of waveform generated will lie in the audible range. The other is called as radio frequency oscillator. Radio frequency means high frequency. So audio frequency means between 20 Hz and 20 kilohertz. Radio frequency means greater than 20 kilohertz. So what are the oscillators that will come under audio frequency oscillator? We will first see Wien bridge oscillator. Then we will see RC phase shift oscillator. They both are audio frequency oscillator. What about radio frequency? Here we will see LC oscillator, in which we will see three type of oscillator: Hartley, Colpit and Clap oscillator, and also the second is crystal oscillator. Crystal oscillator you might have heard about if you have studied microprocessor. Crystal oscillator is used with microprocessor in order to supply the clock signal. Okay, they have high frequency, so it is called as radio frequency oscillator. Okay, so RC oscillator will design a sinusoidal wave, that is, it will be a harmonic oscillator. Okay, LC oscillator will give us the square wave, whereas crystal oscillator will give the sawtooth wave. So RC oscillator sinusoidal, LC oscillator square, crystal oscillator triangular or sawtooth type of wave. So these all oscillators we will cover in the next few lectures in order to understand how does an oscillator work and how it will be used in our system. So in this one I will be teaching you one oscillator, that is the Wien bridge oscillator. Now if you see the structure of this Wien bridge oscillator, you will see the passive components include resistance and the capacitance. So it is also a type of RC oscillator. So you can say there are two type of RC oscillator: Wien bridge oscillator and the RC phase shift oscillator. Okay, so when we are designing for low frequency, we are using R and C. When we are designing for high frequency, we will be using L and C. Okay, so now one thing that we will do here is understand what is the frequency of oscillation of this Wien bridge oscillator and how we will analyze this circuit. Now see this. This branch is connecting output to the positive terminal of op amp. That is why I will call it as positive feedback. And since it is an oscillator, you can see we don't have any input signal because oscillator oscillations are self-sustained. It does not need any input signal. So what is the principle of op amp? In op amp we don't have any input current or current at the input terminals. This both currents will be 0 ampere. That means R1 and R2 are in series, and this branch ZF and Z1 is also in series. So if I ask you the voltage of positive terminal, what you can do? Apply voltage division V0 into Z1 by Z1 plus ZF. What about negative terminal voltage? It is V0 into R2 by R1 plus R2. Now what is the input voltage of the op amp? The input voltage is actually the difference of the positive and the negative voltage. So it is V0 Z1 divided by Z1 plus ZF minus R2 divided by R1 plus R2. Now see, this input voltage is directly proportional to output, so this will be called as your feedback voltage. In oscillator we don't have any input voltage, but the feedback voltage itself works as the input voltage. Now let me write down Z1 and ZF. ZF is R plus 1 by SC. So you can say SC R plus 1 by SC. What about Z1? R dash parallel with 1 by SC dash. That is R dash over 1 plus SC dash R dash. So when you find out this term Z1 by Z1 plus ZF, if I simplify, R dash over 1 plus SC dash R dash over SCR plus 1 by SC plus R dash over 1 plus SC dash R dash. Now it will become R dash over into SC divided by SCR dash 1 plus SCR into 1 plus SC dash R dash. Okay, this I have just simplified the term Z1 over Z1 plus ZF. Okay, now what we can do is we can further simplify by opening the braces. S square R dash C dash plus S CR C dash R dash CR dash plus 1. Okay. Now if you write down beta, what is beta? Beta is the ratio of feedback voltage and output voltage. So it is Z1 over Z1 plus ZF minus it will be R2 over R1 plus R2. That means SCR dash by S square R dash CC dash plus S CR C dash R dash plus CR dash plus 1 minus R2 by R1 plus R2. Now if you want to come into frequency domain, you will replace S by j omega CR dash. J omega whole square is minus omega square plus j omega RC R dash C dash R dash C. Now I told you, when applying Barkhausen criteria, you will replace the imaginary part of beta, or you will equate the imaginary part to 0. In order to find the imaginary part, we will have to rationalize this expression. So I'll multiply the conjugate of the denominator in the numerator. So conjugate will be this. Okay. And in the denominator, what I will have? 1 minus omega square r dash c dash whole square plus omega square rc r dash c whole square. Now if you take out the imaginary part of beta, this term is real, so imaginary part will come from the first term. J into j, that is the second term, will be real, but the first term will be imaginary, because imaginary into real is imaginary. So we will write omega c r dash 1 minus omega square r dash c dash must be 0. It will also have some denominator, this denominator, but since we are equating it to 0, the denominator will not matter. If you are equating it to 0, omega square r dash c dash must be 1, or you can say omega will be 1 by under root r dash c dash, or you can say the frequency of oscillation. From here I have derived the frequency of oscillation. F will come out to be 1 by 2 pi under root r dash c dash. Okay, that will be the value of the frequency produced by this oscillator. Okay, now once we know this, what will be the remaining value of beta? Second term, if you see, j into j, minus 1, minus minus will be plus 1, omega square c r dash rc r dash c dash r dash c by 1 minus omega square r dash c dash whole square plus omega square rc plus r dash c dash plus r dash c whole square minus r2 by r1 plus r2. Now see this thing. When we were equating the imaginary part of beta to be 0, okay, when we were equating imaginary part of beta to be 0, we equated this term equal to 0. 1 minus omega square is this. I will write as omega naught f naught. Here also I will write omega naught. Okay. That means we were equating this 1 minus omega square term to be 0. So this term will also be 0. So what beta remains? Omega naught square cr dash rc plus r dash c dash plus r dash c by the first term in denominator goes to 0. So it is omega naught square rc plus r dash c dash plus r dash c whole square minus r2 by r1 plus r2. This term gets cancelled. This will also get cancelled. So what we will get in beta? We will get that beta is actually equal to cr dash by rc plus r dash c dash plus r dash c minus r2 by r1 plus r2. Okay, that will be the value of beta when we have applied the Barkhausen criteria for oscillations. Okay, is this much fine? Okay, now let me take one case. If r equal to r dash and c equal to c dash, if r equal to r dash and c equal to c dash, what is this oscillation frequency? This will become R square, this will become C square. It will be 1 by 2 pi RC. What about beta? If RC is equal to R dash C dash, it will be 3 RC. It will be RC. So 1 by 3 minus R2 by R1 plus R2. That will be the value of beta. Okay. And you can find out the relation between R1 and R2 if you know the value of A, because A into beta must be 1. Now how to find the value of A? See this figure. This is the amplifier, because in negative feedback we have the amplifier, but for positive feedback we have the oscillator. So what I need is the forward path gain A, and then only I can tell about the beta. Now see, the feedback voltage is connected at the positive terminal, so it is acting as the non-inverting amplifier. See, I told you in oscillator the feedback voltage will itself play the role of input. So if you consider feedback voltage as input, the input is connected at which terminal? Positive terminal. So it is a non-inverting amplifier. What is the gain of non-inverting amplifier? The gain of non-inverting amplifier is 1 plus RF by R1, that is 1 plus R1 by R2, or you can say R2 plus R1 by R2. Now we know that A beta must be equal to 1. So R2 plus R1 by R2 multiplied by beta was 1 by 3 minus R2 by R1 plus R2. This must be 1. So R2 plus R1 by 3 R2, if you multiply it inside, minus 1 is equal to 1. Okay. So how much will it become? R2 plus R1 by 3 R2 should be equal to 2. Okay. Is there some calculation mistake? Let me check once. It will be 1 by 3 minus R2 by R1 plus R2. Okay. And what is the gain of the non-inverting amplifier? The gain of the non-inverting amplifier is 1 plus R2 by R1. 1 minute. We will not go like this. What I'll do is I'll assume an ideal op amp. Okay. We will assume an ideal op amp. What is the gain of ideal op amp? The gain of ideal op amp is infinite. If the gain of ideal op amp is infinite and we know A beta equal to 1, which means beta equal to 1 by A, it will tend to 0. If beta tends to 0, it means 1 by 3 minus R2 by R1 plus R2 must be 0, or you can say 3 R2 is R1 plus R2, or you can say R1 equal to 2 R2. It means if you assume R equal to R dash and C equal to C dash, then R1 must be equal to 2 R2, then only you can design the Wien bridge oscillator. So in Wien bridge oscillator, what you need to remember is the frequency of oscillation, which is 1 by 2 pi under root R dash C C dash. Okay, that is the condition that you need to remember. Is it fine? Also, one more thing that we can do here for the general case. For the general case, what was beta? Beta was C R dash by RC, R dash C dash, R dash C minus R2 by R1 plus R2. For the case of ideal op amp, A tends to infinity, due to which beta must tend to 0, so that A beta equal to 1. If beta is 0, you can say CR dash by RC plus R dash C dash plus CR dash should be equal to R2 by R1 plus R2. If you take reciprocal on both the sides, by CR dash, it is equal to R1 plus R2 by R2. So it is 1 plus R by R dash plus C dash by C is equal to 1 plus R1 by R2. So this gets cancelled. So this is the condition from beta okay. So what you have to remember in Wien bridge? This is the first condition that you have to remember. The second is the oscillation frequency 1 by 2 pi under root R, R dash, C, C dash. If R and R dash are equal and C dash are equal, you will get the condition that we derived earlier, R1 equal to 2R2. You will get from the first one if R and R dash are equal and C dash are also equal. So just remember these two conditions from the Wien bridge oscillator, and remember it is audio frequency oscillator. It is used to generate small frequencies, low frequencies in the audible range from 20 Hz to 20 kilohertz. Okay. So RC oscillators are always used at low frequencies because their response is stable at low frequency. Okay. So if I summarize what we have covered in this video, first of all I have told you about function generator. Then I told you oscillator is an important part of any function generator, and in oscillator we saw Barkhausen criteria, that is for sustained oscillation A beta must be equal to 1. Then we saw that there are two types of oscillator, audio frequency and radio frequency. In audio frequency we have RC oscillator, in which we covered Wien bridge oscillator in this video. In Wien bridge oscillator we saw only passive components were R and C, and we derived two conditions, that is R by R dash plus C dash upon C is equal to R1 by R2, and the second one is frequency is 1 by 2 pi under root R dash C dash, and the response of Wien bridge oscillator is only stable at low frequency. That is why it is audio frequency oscillator. Its response will become unstable at high frequency. That is why we don't use Wien bridge oscillator at high frequency. We only use up to 20 kilohertz. Okay, and that is due to op amp. Is it fine? So in the next video we will cover more about the next RC oscillator, that is the RC phase shift oscillator. That we will cover in the next video. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very, very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very, very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2 year subscription becomes 66600. So the choice is your, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.